Statistics Lesson 9-1, Two Proportions. Two objectives. Conduct a formal hypothesis test of a claim made about two population proportions. Number 2, construct a confidence interval estimate of the difference between two population proportions. Inferences about two proportions. Objectives. Well, the hypothesis test would be one, and the other would be the confidence interval. Hypothesis test, we're going to conduct a hypothesis test of a claim about two proportions. Number 2, the confidence interval. Construct a confidence interval estimate of the difference between two population proportions. Now we have several new notation things here, and let's see if we can. We need to describe them. All right. So P sub 1 will be the first population. First population proportion. And then P sub 2 is, well, it would be the second population proportion. And then we have N sub 1, and that's the number, size of the first sample. Of first sample, and N sub 2 is size of second sample. All right, and let's see, X sub 1, and that's number of successes. Of first sample. And X sub 2 is number of successes. And this of the second sample. P hat sub 1. It's going to be, well, X sub 1 divided by N sub 1. P hat sub 2 is going to be X sub 2 divided by N sub 2. And let's see, we got Q hat sub 1. And that's going to be 1 minus P hat sub 1. And then Q hat sub 2 is 1 minus P hat sub 2. All right, so that's the notation. We're going to use a pooled sample proportion. This is called, this is P hat, called P hat. And this is called P bar. All right, so P bar equals X sub 1 plus X sub 2 divided by N sub 1 plus N sub 2. And Q bar is 1 minus P bar. All right, there we go. Requirements. The sample proportions are from two simple random samples. Requirement 2, the two samples are independent. Samples are independent if the sample values selected from one population are not related to or somehow naturally paired or matched with the sample values from the other population. And number 3, for each of the two samples, there are at least 5 successes and at least 5 failures. So NP hat is greater than 5 and NQ hat is greater than 5. The test statistic for two proportions with the null hypothesis P sub 1 equals P sub 2, we use Z equals P hat sub 1 minus P hat sub 2 minus, and that would be P sub 1 minus P sub 2. But if you're using those equals, then that would be 0. Divided by P bar times Q bar divided by N sub 1 plus P bar times Q bar divided by N sub 2. And you would take the square root of that. Remember, P bar is X sub 1 plus X sub 2 divided by N sub 1 plus N sub 2. And Q bar is 1 minus P bar. All right, that sounds like a lot, but remember, I would put this stuff on a 3x5 card. Confidence interval. Estimate of P sub 1 minus P sub 2, and that, let's see here, that should have been P sub 1 minus P sub 2, and not that way there. It's P hat sub 1 minus P hat sub 2 minus E, which is less than P sub 1 minus P sub 2, which is less than P hat sub 1 minus P hat sub 2 plus E, where the margin of error E, is given by Z sub alpha divided by 2 times the square root of P hat sub 1 times Q hat sub 1 divided by N sub 1 plus P hat sub 2 times Q hat sub 2 divided by N sub 2. Now here's a note about equivalent methods. When testing a claim about two population proportions, the p-value method and the critical value method are equivalent. The confidence interval method is best for estimating, is not equivalent to the p-value method or the critical value method. In other words, sometimes you get slightly different results. Hypothesis test. For tests of hypothesis made about two population proportions, we consider only tests having a null hypothesis, P sub 1 equals P sub 2. So our first example, car license plate laws. Are they equally enforced in different states? In Connecticut, and here we're going to compare Connecticut and New York. Use a 0.05 significance level and the p-value method to test the claim that Connecticut and New York have the same proportion of cars with real license plates only. Okay, so let's see here. Get a little writing room. All right. And let's put it all on this right here. All right. So first we have to do a requirement check. The two samples are simple random samples, and we're going to have to trust that. In real life, we would actually investigate it, but here we're just going to trust that. Number two, the two samples are independent because cars and samples are not matched or paired in any way. And three, a success would be a car with a real license plate only. And you see we got 239 here and we got 9 there, so it passes that. So requirement check. Good. Step 1, the claim that Connecticut and New York have the same proportion of cars with rear license plates only. So we would say this is P sub 1 minus P sub 2, or equals P sub 2. Equals P sub 2. And then step 2, if P sub 1 minus, or if P sub 1 equals P sub 2 is false, then P sub 1 is not equal to P sub 2, which that's going to make that a two-tailed test. Step 3, we're going to have our null hypothesis is going to be P sub 1 equals P sub 2, and our alternate hypothesis is going to be P sub 1 is not equal to P sub 2. Our alpha 0.05, So alpha equals 0.05. And that's our significance level. Step 5, we're going to use P bar. Okay, we'll use P bar. And let's see, that's going to be x sub 1 plus x sub 2 divided by n sub 1 plus n sub 2. So we got 239 plus 9 over 2049 plus 550. All right, so let's go to our calculator. Control divide 239 plus 9 over 2049 plus 550. And that's not working out just right. So we'll 0.095421 equals 0.095421. All right. If that is P bar, then we're going to have 1 minus that. And, oh, see, it went a little bit further. So we're going to have 0.904579. So Q bar, let's see, Q bar is going to be 0.904, 579, yeah, 579, 579. So that there we go. Now, since we're going to do a p-value method, we're just going to do it in the calculator. All right. So we're going to go over here, menu, 6 for statistics, 7 for stat test, and then 2 proportion z-test, 6, and successes, 239, and 2049, and then here we got 9 and 550. And there we go. The alternate hypothesis is that they're not equal to, and we press. So our p-value is, wow, small. So we're going to say our p-value, let's see, 6, our p-value is going to be, p-value is 0.0001. And it's actually less than that, but that's okay. And let's see, we're not going to say equal, we're going to say less than. All right, and our z, or our alpha is 0.05. So p-value is less than alpha. So we reject the null hypothesis. All right, so that's number 7. And then, of course, number 8, and I may need to write that out for you. Let's write that out for you. There is sufficient evidence to conclude that Connecticut and New York have different proportions of cars with rear only license plates. All right. And I guess you might say Connecticut probably does not enforce it as well as it. We'll say the license plate laws are much stricter in New York than Connecticut. They don't apply as very well. Okay. Good job on that. P-value. Now let's do the critical value method. All right, the critical value method. Let's see, I'm going to click on this. And let's move that up a little bit there. And I'm going to get some room here to write. And let's move that up. Now, we've already done the requirement check, right? And it was okay. So, requirement check. Check. And that was okay. We're kind of trusting the author. One, we did this already. It doesn't change. Two, P sub 1 is not equal to P sub 2. 3, the null hypothesis, P sub 1 equals P sub 2. And the alternate hypothesis, P sub 1 is not equal to P sub 2. 4, alpha, all of this is the same no matter which method you're using. And 5, P bar equals, and we did that on the other page, P bar equals 0.09542, and that meant Q bar equals 0.904579. And let's see, we're going to have to calculate the z value. And what do we got? We got, let's see, that's going to be 239 over 2049 minus 9 over 550. You know what I didn't do? I didn't write all this out. So let me write this out so you can, we got, let's draw that like that. We've got P hat sub 1 minus P hat sub 2 minus P sub 1 minus P sub 2 over the square root of P bar times Q bar over N sub 1 plus P bar times Q bar over N sub 2. All right, and that's going to equal 239 over 2049 minus 9 over 550 minus 0. Because remember, we set those equal to each other. So next, and this is going to be a bit more writing here. So we're going to have the square root of 0.09542 times 0.904579 over 2049 plus, and then we're going to 0.09542 times 0.904579 over 550. Let's see if we can put that in the calculator. So we got control divide, and then we got open parentheses, divide 239 over 2049 49 minus, and then control divide, 9 over 550. And we get out of there, and we're going to subtract that from 0 because piece of 1 equals piece of 2. Now we want the square root here. And we're going to have 0.09542 times 0.904579 over 2049 plus, and again we got to put the same thing, 0.09542 times 0.904579 over 550. And what do we got? Z values go to two places, so we're going to say that equals 7.11. All right. So if that equals 7.11, so 7, this is all 6 right here, 7.11 is greater than, oh, we had an alpha. If alpha equals 0.05, what is our Z value? We got menu 6, 5, 0, 5, 1. Oh, I should menu 6, 5, 3, and then we got 0.05 divided by 2. And what do we got here? We got, that stays the same. So we got 1.96. And I'm just going to use, I should have, I guess, done 1 minus that, but I didn't. Menu 6, 5, 3. 1 minus, then open parentheses, 0.05 divide, because it's 2 tails, so we got to divide it up between both sides. So we got 1.96. So Z, therefore Z equals 1.96. So 1.96. So what we're saying here is, we're saying the Z value is greater than the alpha. So reject the null hypothesis, and then 8, write a statement like we did just a minute ago. Okay? And that's the critical value. Oh, can you do that in the calculator? Let's see if we can do that in the calculator. Menu, and it's much easier in the calculator. 6 for statistics. Let's see here. 6 for statistics, and then 7, and then 6, and we did all of that, right? So we got what? 239, 2049, 9, 550. And then see here, our Z value, 7.10. P is not equal to, okay, so there we go. All right. So there we go. And then let's see here. Now let's do this confidence interval. Conduct a 95% confidence interval estimate of the difference between the two population proportions. What does the result suggest about the claim that Connecticut and New York are? Same as before. The requirement check. Check, we've already done it. It was fine. And then one piece of 1 equals piece of 2. All right, we got that. And then 2, piece of 1 is not equal to piece of 2. 3, h sub 0, piece of 1 equals piece of 2. The null hypothesis, piece of 1 is not equal to piece of 2. Okay? And then 4, alpha is 0.05. 5 is where it gets a little bit different. Okay, remember we got z alpha divided by 2. And we calculated that a little bit ago. That was 1.96. Okay? So now let's calculate our E, our error. E is z sub alpha divided by 2 times the square root. And we're going to have p hat sub 1 times q hat sub 1 over n sub 1 plus p hat sub 2 times q hat sub 2 over n sub 2. So that's going to give us, we calculated this a minute, that's 1.96 times the square root. And we're going to have and we're going to have 239 over 2049 times 1810 over 2049 over 2049 plus, and then here we got 9 over, that's 9 over 550 times, and that's going to be 541 over 550. And that's all going to be divided by 550. Okay? So let's try that. Let's try that in our calculator. We're going to have 1.96 times the square root, control, divide. And instead of well, let's see, open parentheses, control, divide, 239 over 2049. Instead of having to keep up with all those decimals. To me, it's just easier to do it this way here. And then it's 1810 over 2049. And then 2049 plus control divide. And then we open parentheses, control divide. We got 9 over 550. Times 541 over 550. And that's over 550. And then we got 0.017482. So E equals 0.017482. So here's where we do our thing. P hat sub 1 minus P hat sub 2 minus E is less than P sub 1 minus P sub 2 which is less than p hat sub 1 minus p hat sub 2 plus e. All right, so let's fill this out. P hat sub 1 was, and we got 239 over 2049 minus 9 over 550 minus, and then we got 0.017482 0.17482 is less than p sub 1 minus p sub 2 is less than, and that's all in parentheses, 239 over 2049 minus 9 over 550. I do it this way so I don't have to keep up with all the decimals. 0.017482. All right, so let's go to our calculator, and we got open parentheses, and then open parentheses, control, divide 239 over 2049 minus, put that in a little bit too soon, minus, control, divide 9 over 550 minus, and I'm just going to go up here and grab this. All right, so that's going to give me 0.082797. I'm going to write this as 0.0828 is less than p sub 1 minus p sub 2. All right, and then let's go up. Here's where it's really cool. I'm going to just go up there and grab that. And I'm going to change that from a minus to a plus. So I don't have to type it in again. And that gives us 0.1178. 0.1178. Okay? So what does that tell us? What does that tell us? We have the confidence interval limits do not contain 0. Remember, p sub 1 equals p sub 2, so p sub 1 minus p sub 2 would be 0. This does not contain 0. All right, it does not have that in there, suggesting that there is a significant difference between the two proportions. Now, if you notice, this is positive and this is positive, which suggests that Connecticut does not enforce which means, well, this shows that Connecticut, since they're both positive, Connecticut has more rear license plate only vehicles, okay, which suggests that they don't enforce it as strictly as in New York. All right, last slide here. Caution. Don't test for equality of two population proportions by determining whether there is an overlap between two individual confidence interval estimates of the two individual population proportions. Boy, that's a mouthful. When compared to the confidence interval estimate of p sub 1 minus p sub 2, the analysis of overlap between two individual confidence intervals is more conservative by rejecting equality less often. And it has less power because it is less likely to reject p sub 1 minus p sub 2, when in reality, p sub 1 is not equal to p sub 2. All right, that's something to be cautious of. Folks, y'all did a great job, and I will see you in class tomorrow. Thank you.